So let's study the greatest common factor and factoring out the greatest common factor. So I already have some notes kind of written on the screen. So pause the video so that you can write those notes down. So my greatest common factor, we have to remember GCF stands for greatest common factor. That's why I have the G, the C, and the F underlined. And that just means it's the biggest or the greatest factor that's in common in all the terms. So theoretically, we've seen greatest common factor with our numbers. So that's why I have this recall written down. And I have the two numbers 12 and 18, and their greatest common factor is 6. So right underneath there, I've placed the reason why the greatest common factor is 6. So next to 12, I wrote down the factors of 12. 1 times 12 will give me a 12. 2 times 6 will give me a 12. 3 times 4 will give me a 12. I didn't bother writing them in order. I just wrote them down right next to each other because while we're thinking of one factor, we could think of the one that matches it and hurry up and write it down. Then I did the same thing for 18. 1 times 18 will give me 18. 2 times 9 is 18, and 3 times 6 is 18. From there, I just went in and I circled any of the factors that they shared. So 1 was shared by both of them. 2 was shared by both of them. 6 was shared by both of them. And 3 was shared by both of them. Then once I look at what I have circled, 6 is the biggest number that's a factor that I have circled in both 12 and 18. So that's the reason why 6 is my greatest common factor. When we advance that to variables, what we're going to do is we're going to look for the smallest exponent. You have to have that variable present, and then once that variable is present, you look for the smallest exponent. So I have x squared y squared, x cubed y, and x to the 4. X squared y squared, comma, x cubed y, and x to the 4. Their greatest common factor is going to be x squared. So underneath there I've written down how I obtained that. So if I have x squared, y squared, that means I have an x times a x so that I can have 2 x's, and a y times a y so I can have 2 y's. X cubed y would be 3 x's and a y, and x to the 4 would be the 4 x's. When I look at these, and I go to do the same thing I did with the numbers, here's an x in each of these, so I'm going to circle it. And notice this time I circled it as one big group instead of individually. That's so that you can see which set was being circled. So I have one set of x's here. I have another set of x's here. When I get to the y that's in the x squared y squared, I don't have another y to put with it from the x to the 4th. So that's the reason why the variable has to be present, because if it's not present, you won't have one that's shared by everyone. You run out. And technically, this y would be a y to the 0, meaning no y's. And so I don't need to write no y's. So if I look at the x's, notice that the smallest number of x's I had was 2, because I ran out of x's on that x squared y squared to use with the x cubed y or even the x to the 4. Notice that 2 was the smallest exponent on my x. So this part in purple and blue, this is how we know that this is all we're going to do, is make certain the variables in each term and use the smallest exponent that's on that variable. We're going to go ahead and we're going to determine the GCF of 28x cubed y cubed, negative 21x squared y squared, and 14y to the 4th. So let's think of our numbers first. For 28, we have 1 and 28. We have 2 and 14. we have 4 and 7, and that's about it. For 21, we have 1 and 21, and we have 3 and 7. For 14, we have 1 and 14, we have 2 and 7. So we have a 1, and we have a 7. So the greatest common factor for the numbers is going to be 7. Now we have to look at the variables. First term has x's. Second term has x's. The third one does not. So I'm not going to be able to use an x, but I will be able to use a y. First term has 3. Second one has 2. The last one has 4. The smallest number of y's is 2, so that's the most I'll be able to take out of everyone. So my greatest common factor is going to be the 7 y squared. Now let's take a look at factoring out that greatest common factor. So again, pause so you can write down what I already have on the page, and then we'll come back and work the problem. So if I need to factor out the GCF, the first thing I'm going to have to do is determine the GCF, and that's going to be one of my factors. My second step is going to be to divide each term by the GCF, so I can get, oh, I have a correction here. On here I have second term written down. Please fix that. It should say second factor. What I'm doing when I'm factoring out the GCF is I'm trying to find out what I started with originally, so that when I multiply, like that's going to be the what we started with will be the answer. Okay? And that's how we check it. So we can actually add another bullet here where we say to check our work, so let's get into number 1. First thing I have to do is figure out my GCF. When I look at the 9, the 27, the 18, and the 6, if I'm getting used to my factors, my greatest common factor is going to be a 3. Don't be tempted to say it's 9, because you have a 9 in the first term, a 9 in the second term, and a 9 in the third term. Because you have 9 times 1 is 9, 9 times 3 is 27, and 9 times 2 is 18. But I don't have a 9 in the last term. My greatest common factor cannot be bigger than any of these terms. If it ends up being bigger than any of those terms, it's not the greatest common factor. So you may want to put an asterisk on your paper. Even go back to where we talked about the greatest common factor initially. Put an asterisk on your paper and put that little reminder that the number that you're using, it can't be bigger than any of the numbers in the other terms. So I can't have a 9 because 9 is bigger than 6. So 3 is going to be my number. I have to check for my variables. I have a y on the first one, a y on the second one, a y on the third one. That last piece is just the constant plus 6. There's no y there. That means I don't have a greatest common factor that has a y in it. So what I end up with is a 3 that I'm going to pull out as my first factor. I then have to take what they gave me and divide each of those by 3. Nine y to the 6 divided by 3 is going to give me a 3y squared. I pulled out a positive 3, so I can just copy these signs down. So I'm going to just copy down that minus that's right here in front of that second term. A 27 over 3 is a 9. I didn't have a variable, so I just copied down my y to the 4. Plus is in front of that third term, so I'll write that down. 18 divided by 3 is 6. Again, there's no variables in the denominator, so my variable will be untouched. On the last piece, 16 over 3. I'm sorry, I wrote 16. That should have said 6. 6 over 3 is going to give me a 2. It's a positive, so I have a positive 2. And now I've factored out my greatest common factor from my polynomial. When we're doing these factoring out the greatest common factors, when we did dividing by taking a polynomial and dividing by a monomial before, we had answers where maybe you had a variable in the denominator or something left in the denominator. When we're doing this factoring out the GCF, we shouldn't have something left in the denominator. We should be able to pull that out. The only way you should see something left in the denominator is if in your polynomial you originally had fractions. So if you had a fraction for a coefficient or a fraction for a constant, that's the only way you should have a fraction in your answer. Let's do a second example. So in this example, I don't really have any coefficients to worry about. My coefficients for each term is either 1 or -1. So I don't have to worry about the numbers. I just have to pay attention to my variables. The other thing I'm going to pay attention to is the fact that that very first term starts out with a negative in front of it. So I have negative x to the 9, y to the 6, plus x cubed, y fifth, minus x to the 4, y cubed, plus x cubed, y cubed. That minus in front of that very first term is what I need to pay attention to. I'm going to have to use that as part of my GCF. And that's just a rule that we use so that it helps us with our factoring. We're going to always take that negative out with us as part of the greatest common factor when that negative is up front. And we call that factoring out the negative. So now I'm going to use a negative. I'm going to check my x's. First term had 9 x's, second one had 3, third one had 4, the last term had 3 x's. So every term has an x. The smallest number of x's is 3. So I'm going to use x cubed. Now I'm going to look at my y's. I have 6 y's in the first one, 5 in the second, 3 in the third, and 3 in the fourth. So each term has a y. 3 is the smallest number of y's, so I'm going to use a y cubed. Now I have to figure out what I'm leaving behind to put inside the parentheses for the second term. And to do that, I'm going to do my little division part. I'm going to take each term and I'm going to divide it by our greatest common factor of negative x cubed y cubed. Because I'm dividing by a negative, I automatically know that my signs are going to change from how they were originally written in the polynomial that they gave us. So that's the first thing I'm going to notice. So a negative divided by a negative is going to give me a positive that as my first piece to write inside the parentheses. X to the 9 divided by x cubed is going to give me an x to the 6. A y to the 6 over a y cubed is going to give me a y cubed. Remember when we're doing that division, we're subtracting the exponents. When I go to the second term, I have a positive divided by a negative, so it's changed to a negative. I have x cubed, same number of x's, it's gone. A y to the fifth over the y cubed, that's going to leave me with 2 y's. A negative over a negative is going to give me a positive. An x to the 4 over x cubed, 4 minus 3 is 1, so that's going to leave me with 1x. A y cubed over a y cubed means my y's are gone. Then I'm going to have a positive divided by a negative to give me a negative. An x cubed over x cubed, those x's are gone. Y cubed over y cubed, those y's are gone. I have to leave something back there to hold its place, and I'm going to leave back a 1. If I'm talking too fast, pause it. Write down the extra notes you need to write down on the problem, and then go back and hit play again. If I want to check my answers, all I have to do is multiply things back. So I take what I have for my answer, I multiply. So taking the negative x cubed y cubed, multiplying it by x to the 6 y cubed, is going to give me this negative x9 y to the 6 that we had originally. Remember, when you're multiplying, you end up adding the exponents. The negative x cubed y cubed times the negative y squared is going to give me that positive x cubed y to the 5th. Negative x cubed y cubed times the positive x is going to give me the negative x to the 4 y cubed. Negative x cubed y cubed times the minus 1 is going to give me the positive x cubed y cubed. The goal is to eventually get to the point where the part that I've written down in blue, you don't need to write down anymore. So if you pick up on the pattern and you recognize the pattern, you don't need to write that part that I've written down in blue, which is just taking the original polynomial and dividing by the greatest common factor. If we go back to number 1, staying on number 2. If I have 3 x's that I pulled out and I started with 9, that's going to leave me with 6. Because when I'm pulling them out in terms of multiplying and dividing. And so when I'm pulling it out, I'm really dividing, which means I'm subtracting exponents. So if I take 3 x's from the 9 x's, I'm going to have 6 x's. If I take 3 y's from the 6 y's, I'm going to have 3 left. And so I can get those without writing the blue. If we look back at number 1 in terms of the numbers, if I have 3 that I'm pulling out, and remember when I'm pulling it out with division, and if it's a plain old number, that means I'm just dividing. So 3 goes into the 9 the 3 times. 3 goes into the 27 the 9 times. 3 goes into the 18 the 6. 3 into the 6 the 2. So that's the goal, to be able to see that without writing the blue. In the meantime, you write the blue if you have to write the blue. Let's do one last example. And this last example is leading into what we're going to do for the next type of factoring. On this one, I have sort of like 2 pieces here. And in each of those pieces, I have some multiplication going on. What's separating out this piece? This minus sign right here. The first piece is the x times, in parentheses, y squared plus 1. The minute you see that parentheses without a symbol, like a plus or a minus in front of it, that meant it was being multiplied by the x. So I'm going to count that as one big group because there's multiplication there. And then behind my minus sign, I have the same thing going on. I have 3 times the y squared plus 1. So I'm going to take that as one big group. Out of those pieces that I have, I'm still going to look for my common factor. This time, my quiet factor is the entire parentheses that matches. And so when I have that matching parentheses, it acts as my common factor. So my first factor is going to be the y squared plus 1. It's a whole piece together, so I'm going to use a parentheses. And now I have to write another parentheses to see what I leave back behind. On this one, see if you can kind of envision it without writing down that division part, and then I'll go back and write down the division part. That x times the parentheses y squared plus 1 is the first part. If I pull that y squared plus 1 out, it's just going to leave me with the x. So that's what I'm going to write down for my first parentheses. I'm going to copy this minus sign down. And now I'm going to go in and look at the second piece. I have the y squared plus 1. That's what I'm taking out. And if I mark that out in my mind, all I'm going to have left is this minus 3. So that's what I'm going to write down. I already wrote down the minus, so I just need to write the 3 down. And this is going to be my answer for number 3. If I need to, what am I doing? I'm doing something that looks like this. And we really haven't dealt with that yet. And that's why I was asking you to envision it. Okay. So I have that. And here I have a matching piece with a matching piece means it's not there anymore. A matching piece with a matching piece means it's not there anymore. And again, because we haven't really done that part yet, I'm going to go back and erase that. Here's your common part. And that's what's being written here. You're not writing it twice. You're writing it once because it was in common. What's ever in common gets written here once. What I have written here in the second parentheses, that's the what's left. And there's our greatest common factor. And factoring out the greatest common factor.